Mentioned in class that it is not on the test tomorrow. However, it is on the midterm. If I look at this first one and I see a 2, a 32, and an 8, I am just going to divide everything by 2. In this case, I actually divided everything by -2. I might as well just get rid of that. So I divided everything by -2 to get to that line. And then to complete the square, I moved the 16 to the right side. I moved the 4x to the left side. I found the perfect number of 4. We find that by taking this number, dividing by 2, and squaring it. If I add 4 to the left side, I add 4 to the right side. I then complete the square on the left side. Then I take square roots. The square root of 20 is 2 radical 5 because 20 is 4 times 5, and the square root of 4 is 2. And then I subtract 2, and I get that final answer. Okay. Solve by factoring. This one's a hard one because that coefficient is 6. Now, when you see that coefficient is 6, it really can be a 6 and a 1 or a 2 and a 3. It doesn't matter. Just guess 2 and 3 and then kind of go through the options. If this is 20, you're going to look at 1 and 20, 2 and 10, 4 and 5, and then 5 and 4 and 10 and 2, like all the flips of those. And it turns out that when you look at this one, you're going to get the -5 and the 3x is going to give you a -15x. And then if you look at the 2 and the 4x, that's going to give you an 8x. -15x, positive 8x combined to give you that -7. So then you know you factored it correctly. And then again, once you factor it, then you solve 5/2 and -4/3. Quadratic formula, there's nothing to do. You could, in theory, simplify first, but there's no shared factor between 3, 6, and 22. Everything is already on the left side, and it's already in the order x squared, x number. So this is just me doing the quadratic formula. Again, there's a negative sign there, and there's a -22. So I'm going to end up doing 36 plus 4 times 3 times 22. And I get 300. 300 is 100 times 3. Square root of 100 is 10. Then when I get here, I can take a 2 out of all these. 2, 2, and 2, and I can get this. This or this is fine. Solving with square roots. I'm going to subtract 42 from both sides to get it over there. Then I'm going to divide by -9. -50 divided by -9 is just 50 over 9. Then once I get to this point, then I'm going to take square roots. Don't take square roots right away. Get rid of stuff first. Get rid of the number, get rid of the division, get rid of the multiplication with division, then go ahead and use square roots. The square root of 50 is 5 radical 2, right? 50 is 25 times 2, and the square root of 9 is just 3, and then add the 6 over to finish. Again, this is totally fine just to leave it like that. Same thing over here. This one's going to be annoying because it's going to be fractions. Again, not on the test tomorrow, but it is on the exam. I divided everything by 2. Actually, I divided everything by -2 in the get-go. I like where everything is. I have my square x's and the numbers on the other side. And I'm going to divide this number by 2 and then square it, right? 7 divided by 2 squared is 49 over 4. So that's that magic number I add to both sides. I then factor, take a square root, and then subtract 7/2 over at the end. Again, the square root of 99 is 9 times 11. The square root of 9 is 3, so this is 3 radical 11, and the square root of 4 is just 2. Leaving it in this form is just fine. Solve by factoring. Looks like the first thing I did when I saw that is I got rid of all the negative signs. Why not just make them all positive? We always want our lead term here, that 8, to be positive. And then I double bubbled. 8 is not a prime number, so it could have been 8 and 1, or in this case 2 and 4, ended up being 2 and 4. 35, well, the only factors of 35 are 1 and 35 and 5 and 7. So play around with it for a little bit. And when you get the -7 and the 4, you get a -28x, and then you get another -10x from there. And then you're like, oh, look at that. It combines to make -38x. And then you factor, and then you set them both equal to 0 to solve. Quadratic formula again, it's in the right order. It's equal to 0, so it's just A, B, and C, and you just plug it in the formula. Right? In this case, the square root of 256 is exactly 16, and then you can get -4 plus 16 over 10, -16, or -4 minus 16 over 10. And again, I have no idea. That's clearly 6/5, and I was stupid, and I didn't fix it over here. So that is supposed to be 6/5. Okay, let's look at solve by square roots again. Again, we're going to get rid of the 11 first. Then we're going to divide by -8. Just go in order. And then you get to this step right here, and you're like, oh, okay, time to take square roots. Now, this one's a little more challenging. This is just, sorry, but this is just a little rough algebraically. The square root of 75 is 25 times 3. The square root of 25 is 5. So that's where that comes from. 8 is 4 times 2. The square root of 4 is 2, and the other 2 has to relax. That's where that comes from. The negative makes the I, and then what I have to do to rationalize this thing, right, to get rid of the square root in the denominator, I have to multiply top and bottom by radical 2. Multiplying the top by radical 2 is why it made it radical 6, and then radical 2 times 2 is 2. 2 times 2 is 4. And then you're done. So I agree. That answer is kind of gross, but it's got everything in it. It's got an imaginary number, it's got simplifying square roots, and then it's got rationalizing at the end. All right, now more Unit 4 stuff. Solve using difference of cubes. Remember, if it just said factor, if it says factor difference of cubes, we'd be done right there. But it says solve, so we have to keep solving. This guy right here is easy. That's that front term. This is just 2x cubed, and then this is 5. So we get that. And then to solve that inside, you have to use the quadratic formula, which I've done right here. Again, very similar. Got to rationalize. You're going to have an imaginary number because you got the square root of a negative. 300 is 100 times 3. And then since all of these guys have a 2, 10, 10, and 8, I can make it 5, 5, and 4. And I could write it like this, or I could have just wrote it as -5 plus or minus 5 radical 3i all over 4. It wouldn't have mattered. Okay, here's the sum of cubes. Again, first thing you want to do, always, 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 is factor out the greatest common factor. So me factoring out this 2x then leaves me with this. So I have a 2x chilling. Then I factor the sum of cubes to this guy. And then the easy ones is this solution is 0. This solution is -3. And then to do this guy, it's just like the one over here, I have to use the quadratic formula. So when you use the quadratic formula, I get that guy. So again, it's x to the 4th, and you're going to get 4 solutions. 0, -4, and then 2 imaginary. Solve using the difference of squares. Well, the first thing you're going to do before you do anything is make sure to factor out the greatest common factor. So take out a 2x. And then you're like, oh, look at that. 81x to the 4th minus 16. That's a square. 16 is a square. So we can factor to a minus b, a plus b. And you're like, oh, no, look at that. Even when I factored it to that factors again. 9x squared minus 4 is its own square minus square. So then we do 3x minus 2, 3x plus 2. This chills. That doesn't factor anymore. The sum of squares does not factor. Okay? So now we have to look at all the solutions because, again, we're solving. So this gives you 0. These two give you plus or minus 2/3. And then this one, it's going to give you some imaginary solutions. You don't need the quadratic formula. You can just use square roots. So this is what I'm doing down here. I set 9x squared plus 4 equal to 0. Subtract 4, divide by 9, take square roots, and boom. And I got that. And again, if you look at it, you have x to the 5th. You should have 5 solutions. 0, plus or minus 2/3, plus or minus 2/3 I. 1, 2, 3, or excuse me, 1, 2, 3, 4, 5. Okay, so difference of squares, difference of cubes, sum of cubes, greatest common factor, sum of squares, or difference of squares again in that, quadratic formula, imaginary numbers, and then the last one, solve by factoring with grouping. That's when you have 4 terms. First thing, align them, get them equal to 0, and then factor stuff out from just the first 2 terms. Take a 9x out, and then you can take a 4. And then what you have is you're like, oh, look at that. I created a 3x minus 5 and a 3x minus 5. Now take a 3x minus 5 out from both of them, leaving behind 9x squared plus 4. And it just happened that it was the same thing. So we have, this is easy. That's just 5/3. And then this right here, we have to do exactly what we did right over here. Set it equal to 0, use square roots, and find. And And again, x cubed, you're going to get 3 solutions. 5/3 plus or minus 2/3 I. Okay, so on the test tomorrow, you absolutely will have to solve by factoring, solve by grouping, difference of squares, difference of cubes, sum of cubes, factor out the greatest common factor. Occasionally, you're going to have to rearrange it first, so it's not like it's always equal to 0. Like, look at this guy, right? You're going to have to rearrange that. Sometimes you can divide everything by 2 or 3 to make it a little easier, but this is all about factoring and solving by factoring. Okay? Please go over this review, and then you can look at yesterday's stuff to really hone in on the Unit 4 stuff, but you definitely have to do this on the test tomorrow. Hopefully this video helped.